Oh yeah.
CNAD. Chemistry. Go on, do it for me.
pH.
Now watch me pick.
Kill it.
Now watch me say.
Okay.
Now watch me pick the strongest acid. Once upon a time, a few reactions ago, I was a charge in your sight. You got positive. You're an acid, sid. I guess you didn't care about the negative, and so I like that. I understood charge. You're an acid, sid.
When choosing between strong acids, always choose the positive molecule over the neutral and negative.
Positive charge is always the strongest acid. So here, I'm on the periodic table.
I'm electronegative.
Doing it up like fluorine. Now you say I got a charge. So good. Make you never want to leave. So don't. Gonna hold that hydrogen so tight. I'm a binary compound. And I'm stronger down and to the right. Oh yeah. Cause I just wanna be acidic. Be acidic. I just wanna be acidic. Be acidic. Alright, so this rule only applies for binary compounds, meaning that there's only two molecules in the compound. So for this rule, acidity increases as the electronegativity increases across the row and to the right. And the second rule that goes with this is acidity increases as size increases going down the column. I'm like, hey, what's up, hello? Seen your acidity soon as you came in the dough. I just wanna chill, got a conjugate to thrill. Resonance, stabilize, introduce bond flipping. Showed her how to flip it, now she resonance for show. She my bass queen, let her hit the O-chem. We be counting up bonds, how far them things go. Alright, so this rule follows R, which stands for resonance in the cardio rule. And in this case, so this is when you have to compare between two structures. And so we're asking here which one of these structures is more acidic, and we're going to determine that based on which one has more resonance stability.
In phenol, you have a lone pair of electrons that can shift over here, forming a double bond. This double bond will move right here. This one will move right here, and this one will shift outwards, causing a flush charge right there. This structure is resonance.
Okay, so this structure is almost identical to this one, except there are no double bonds inside the ring. So when a structure is written like this, it's implying that there are hydrogens completing every carbon so that it has 4 bonds. So because there are hydrogens here, this lone pair cannot move in to make a double bond because it cannot kick off this hydrogen. Therefore, this lone pair has to stay here and there is no resonance stability. Therefore, phenol is more resonance stabilized and in this case is more acidic. Hey, we got a good thing. Don't know if I'm gonna see that hydrogen again. But that is a good thing, because that's what acids do. Yes, ma'am, I know it's on your brain. Polar covalent bonds, like their partial charges, and how they donate protons.
DI stands for dipole induction in cardio.
Okay, so dipole induction, basically has to do with dipoles, and dipoles represent the differences in partial charges between molecules, and this rule only applies for polar covalent molecules. So partial charges look like this on two molecules, and the dipole is going to pull towards the more negative partial charge. So dipole induction favors more electronegative atoms. So in these three examples, fluorine is a very electronegative atom, and it's going to want to pull this hydrogen off each of these molecules. So this molecule is going to be the most acidic because it has the most electronegativity and the most negative partial charge in this direction, so it's going to have a very strong dipole going this way, and it will pull off this hydrogen, so it's most acidic. This would be next most acidic because it has two fluorines compared to the other two. And it still will pull off the hydrogen, but not as strongly as this one. This one, the dipole induction is actually pulling this way because of these two pulling the hydrogen this way. So between these three, this is the least acidic and this is the most acidic. What's your domain? Oh, when you're an sp2 or an sp3, what's your domain? Hey, yeah, when you have less domains, you are more acidic. What's your domain? Oh, what's your domain? So we're running out of time. What's your domain? Oh, you understand. Better make up your mind when choosing acids. Okay, so the O in cardio stands for orbitals, and Nadine's going to give you some examples.
So in SP, for an example, you have the C triple bond C, which is linear, and the bond angle is 180 degrees. SP2, an example would be a C double bond C, where your bond angle is 120 degrees. In SP3, you have your C where your bond angle is 109.5.
Okay, so in regards to orbitals, SP is always going to be more acidic than an SP2 molecule than an SP3 molecule. So something like this is going to be more acidic than something like this, which will be more acidic than something like this.